So, welcome to Business Math. I'm your tour guide in this wonderful journey, and we're going to start with fractions. And I'm going to refrain from eating the M&Ms until the experiment is complete. Plus, you don't want to hear me eating M&Ms on air, do you really? So, every PowerPoint slide that we have is going to have a little bit of a roadmap and objectives to it. So, what this is one, I mean, it's kind of easy because the title of the slide deck will kind of tell you what we're covering, but it kind of gives you insight as to kind of what we're covering throughout the lecture before you get into it. So like if you're reading these ahead of time, you can kind of see what are we doing and how are we doing it. So here what we're going to do is we're going to talk about the three types of fractions. Those are proper fractions, which is where there's a little over a lot. There's improper fractions where there's a lot over a little. And then there's a mixed number where you convert the excess in the numerator to a whole number and then have a little bit left over. We can convert these back and forth between all of the types. And then we can convert these into their lowest terms and their highest terms. So like 4/8 can simplify down to 1/2. So like if you have 8 slices of pizza, you eat 4 of them. Did you eat 4 slices or did you eat half the pizza? Well, they're both the same thing. Then we'll learn about how to add and subtract fractions. So if you have a common denominator that's very simple, just add the tops. But of course, most of the time it's not that simple. So then you have to convert the bottom to something that's common. So then you have to convert the top to something that's consistent with the bottom, and then you can do the same thing that you would have done if everything was the same, subtracting the same thing. So it's just basic arithmetic, but fractions have extra steps because they aren't whole numbers. So I think the first chapter, which I skipped, was whole numbers, like the number line, negatives, positives, things like that. And then multiplying and dividing fractions. Honestly, I think multiplying fractions is easier than adding and subtracting them. It's like the only time in human history or area in which like multiplication feels easier than adding and subtracting things. But in a way, multiplying things feels easier because then it eliminates a lot of these crazy conversions that you have to do. Division is the same, but because you're working in reverse, it can be a little bit tricky. But overall, these are the things that we'll cover related to fractions. Fractions are, I think fractions are interesting because fractions are more applicable to what we're used to in terms of like visualizing things. If you think about things as like I ate half a pizza or the glass is half full or half empty or stuff like that, that's kind of thinking from a fraction perspective. And then when you think about money, you think about decibels or percentages and things like that. But this is kind of where we first we realize that numbers are divisible. We can break them down into smaller units. It allows for money to be broken down into smaller units. And so this is a nice starting point to where our discussion is going to be. So the first things first is I'm going to teach you about a proper fraction. So some of this might seem like seriously we're doing this, but the reality is like terminology, it might have been a while. You might not have experience with this. You might not know what I'm talking about. And we're all in different locations. So we're just finding common ground here. And maybe it'll help give you some new tools if you do know how to do all this stuff, but you're very slow at it or like you struggle sometimes. It gives you some new techniques. So first things first, what is a fraction? A fraction basically is a number that is not a whole number. A whole number means that you've got 2, 5, -14. A fraction basically is a representation of a partial number, or a mixed number or an improper fraction. It's a whole number plus something extra, a remainder. The most important things when it comes to a fraction are the top and the bottom and knowing what they are and what they represent. The top of a fraction is known as the numerator. The numerator is basically what you have. The denominator is what constitutes a whole of something. So the numerator is what you got. The denominator is basically what a whole version of what you have would look like. And it's always separated with that little bar in the middle. So all of these are proper fractions. Again, the top is the numerator, the denominator is on the bottom. So when I start using that terminology, numerator is top, denominator is bottom. Num is top, denom is bottom. So all of these are proper fractions. And the reason why they're proper is because the top is less than the bottom. If the top is greater than the bottom, then it's considered improper. If there's a whole number in front of it, then it's considered a mixed number, and those are the three major types. So 2/3 is a proper fraction. 1/4, 1/2, 4/7, 18 55ths. So all of those are proper fractions. Now, a proper fraction doesn't have to necessarily be simplified. There's a difference. So I want you to know that difference as well. A proper fraction just says that the top is smaller than the bottom. But a simplified fraction means that you can't break it down into anything smaller than its existing value. So like 4/8. So if you have an 8-slice pizza and you eat 4 slices, then that means that you have eaten 4/8 of a pizza. But if you realize 4 and 8 have common factors, meaning that like 2 times 2 is 4, 2 times 2 times 2 is 8, meaning that you could split it down and break it down into half. Now, logically, it makes sense because it's half, because you see that half the pizza is missing. But the reality is that there's going to be a mathematical way to break it down from 4 to 1, and then 8 to 2, and then you have 1/2. But just because something isn't simplified doesn't mean that it's not proper. Proper just means that the value is less than 1, that the numerator is smaller than the denominator. Improper fractions. So when something is an improper fraction, it doesn't mean that there's something wrong with it or there's something wrong with you. Like, if you like to live in a world where everything is 79/77, good for you. You're not being improper. It just means that the fraction is improper, but it doesn't mean that you are improper. The first one that everyone asks about is if they're the same, is it improper? And the answer is yes. Because 15/15 is 1. It's a whole number. And so if you're expressing a whole number as a fraction, then it's considered improper. 9, but most of the time what you're going to see is it's going to be that the numerator is greater than the denominator. The numerator is bigger. The top is bigger than the bottom. So 9/8, 9 is bigger than 8. 15/14, 15 is bigger than 14. 22 over 19, 22 is greater than 19. So does everyone know what pi is? Like if I drew the symbol, you'd be like, okay, that looked like pi is just this number here. It looks like this. It's a movie in black and white. It's delicious dessert. It's a bunch of different things, but pi is a Greek letter, and it's basically a math. It has a numerical value. And when we get to decimals, pi has like an infinite number of digits, but basically pi is used in calculating areas of circles. It's used in a bunch of different other calculations, but mainly it has to do with circles and things like that because it's a calculated constant that's representative of like circumference and things like that. So the reason why I bring up pi is pi is like 3.14159. Whoops, not I think it's 59, not 95. I didn't get I didn't force to memorize it. I think it's 3.1415927. The funky thing about pi is that the digits are never consistent. Just keeps on going. So 15927, I guess I rounded it off. So I guess I've remembered the first 6 plus 1 rounded off digits of pi. So the reason why I'm bringing this up is not because you need to know this, but most of the time, if you wanted to substitute pi, if you didn't have like a calculator where you could type in 3.1415927 da 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 da, what people usually substitute for pi as a simplifier is 22 over 7. 22 over 7 is approximately the same as pi. So that's the reason why I'm bringing this up, because you would think, oh, couldn't they just do 3 and what is that? 1/7? Couldn't they just do 3 and 1/7 as a mixed number? Wouldn't that be more proper? They don't. They use 22 over 7. And so 22 over 7, aka the fractional representation of pi, is an improper fraction. But a lot of times, like if you ever plan on going to graduate school and you end up studying for a test that's known as the GRE, a lot of times they'll say just use 22 over 7 as pi, and you'll get basically the same answer as if you used pi itself and typed it in all those digits into a calculator. And honestly, the rounding of all that other stuff isn't enough to justify changing it. And if you plugged in 22 divided by 7 into your calculator, you would get 3.142857. So it's not exactly the same, but it's pretty darn close. And they could have used a crazier like number. They could have used like a very big numerator and a very big denominator to get it really close to what it is, but this is close enough to the approximation. But it's another example of an improper fraction. So improper fractions, just the numerator is greater than the denominator. And then your third number, I apologize for the formatting mess here. I don't know what happened, but mixed numbers are basically when you have an entire whole number, but there's something extra. So notice how 22 over 7 for pi, if you wanted to break this down into a mixed number, which I'll show you in a second at how to, it would be 3 and 1/7. So I'm just going to ignore all these messy ones over here. So 7 and 1, let's just say 7 and 1/9 is what I'm supposed to be showing you. So that means that there are 7 wholes and then 1/9. So that means that, let's say that you have materials to build some sort of thing. You're able to produce 7 of them, but you have enough materials for essentially 1/9 of it. But if you're trying to sell them, you can't sell 1/9 of something. You can only sell the whole thing. So you could presumably sell 7 units, and then you have 1/9 worth of materials, where if you could couple it with something else, you might be able to make additional product. So a mixed number basically just means that it is a whole number accompanied with some sort of remainder value. The definition here is that that remainder value needs to be a proper fraction, because let's say that you had 22/7, you converted it to 2 and 8/7. Well, that's not really a mixed number because it's like a whole number plus an improper fraction. You could easily just convert this to 3 and 1/7. So a mixed number properly expressed is as many wholes as you can get out of it, wholes with a W, and then whatever's left over relative to whatever the lowest common denominator is. So proper fraction, numerator, which is the top, is smaller than the denominator, which is the bottom. Improper fraction, the top is greater than or equal to, so it could be the same as the bottom or larger than the bottom. Improper fraction. Mixed number is a whole number with an attached proper fraction. So if we want to convert improper fractions to whole or mixed numbers, I've kind of shown you how to do it already. Basically, what you're going to do is you're going to divide the numerator by the denominator. So if it's been a while since you've done division, fractions essentially are division problems, especially if it's an improper fraction. An improper fraction is literally just a good old-fashioned division problem. You want to convert it to a fraction, you want to convert it to a decimal, stuff like that. When we get to decimals, it'll be easier to divide into decimals than it is here. So in this example, we have 15 fifteenths. Well, how many times does 15 go into 15? 1. Is there anything left over? No, because 15 minus 15 is 0. So your answer there is 1. If there is no remainder, then your quotient. So what is a quotient? The quotient is the final answer of a division problem. A product is the answer when you have a multiplication problem. A quotient is the answer when you have a division problem. If you have no remainder, then the answer is that you have a whole number. So 15 over 15, they go into each other an equal number of times. You have a whole number. So if you had like 30 over 15, it's still a whole number. You just get 2 instead of 1. Now, what if we have 16 fifths? Well, the first step you have to do is you need to divide 16 by 5 and see how many times does 5 go into 16. Okay, well, you can do it however you want to. You can go 5, 10, 15, up 20 is too much. So I have 3 holes and then I have something left over. You can do it however you want to. You can do a formal division problem like here where you have the numerator on the inside, the denominator on the outside, and you put this little like 90-degree line there to separate what's being divided from what you have. However you're comfortable with. But regardless, when you divide 16 by 5, you get 3. And then when you do 3 times 5, you get 15. So when you do 16 minus 15, you're left with 1. And that 1 can't go into 5 at all, but we were dividing by 5. So that means that the leftover is 1/5. So we have 3 and 1/5 is our quotient or our mixed number. Back during I think it was like a Super Bowl commercial a couple years ago, there was like this Microsoft commercial that turned into a meme where it was some math teacher that was rapping about math, and he was like, we call it the remainder, it's the number that remains, which, I mean, look out, Kendrick Lamar. We've got a poet laureate on our hands with that kind of rap. But so I put that in the thing so you can see like the 3-second clip that came from the commercial. But I actually dug further and found the full rap song, and I don't think it's that bad. If you don't feel comfortable with fractions, you'll actually come away from it, I think, knowing fractions better. I didn't memorize it, so I can't tell you why it's good. But if you go and listen to it, give it a listen to one time and think about, okay, he repeats everything. And so like the numerator is the top, denominator is the bottom, the remainder, if you have a mixed number, is the number that remains because you don't have enough of it to go into the next one. So basically converting an improper fraction into a whole number or a mixed number is just division. So if you'd like a refresher on division, I'm happy to do that. If not, we'll keep moving forward. So this R here stands for the remainder. So that means that, oh, we had one left over based on the division. So the remainder is 1. And then whatever your remainder is just becomes the numerator of your leftover proper fraction. And the denominator becomes this. So this remainder is your numerator. This 5 is the denominator. That's your leftover proper fraction. Now notice that this one is simplified because you can't get smaller than 1 on the top. So if 1's on the top, you can almost, you're always going to be done with simplification. But it could be that, let's say this was 17 over 5. Okay, if this is 17 over 5, oops. If this is 17 over 5, then we do 17. Actually, I don't want to do 17 over 5. I want to do, darn it, 5 is a prime number, so I can't simplify this anymore. Let's use a different example. Let's say that we have 17 over 6. Will that work? No. Let's say we have 16 over 6. Okay. If we do 16 over 6, then that means that if we do our division problem, 16 divided by 6, how many times does 6 go into 16 completely? Twice. So we do 16 minus 12, we're left with 4. So our remainder is 4. 2 remainder 4. So our mixed number would be 2 and 4/6. That's a proper mixed number. That's a proper fraction and a whole number with it. But it's possible that this number could be simplified into something else, because 4/6, you can divide both of these by 2 and get 2, and you can get 3. So actually the answer is 2 and 2/3 instead of 2 and 4/6. So both of these are mixed numbers, 2 and 4/6, as well as 2 and 2/3 are both mixed numbers. But one is simplified and one is not, and that's where we're headed in a second. What if we want to convert a mixed number to a proper fraction? Question about simplification. So when it comes to the quizzes, chances are there will be specific requirements on the question about simplification, or if it's a multiple choice question, the simplified answer will be the only one that's available that would match up with what you got as an improper fraction or a mixed number. So I would get in the habit of simplifying, but there will be some problems where I won't care and I won't ask for it, but other problems where I will specifically ask for it. So make sure that when you're looking at the question that you're answering what I'm specifically asking. So some questions might be like, express as an improper fraction, express as a mixed number, or simplify. So just make sure that you're reading the question. I'll make sure that I'm very specific about what the requirements are for that question, so you don't have to guess what you should be doing. But good question. So if we are converting in the other direction, if we're going from a mixed number to an improper fraction instead of an improper fraction to a mixed number, that's going to involve multiplication. And the reason why you should think about it like that is because of the fact that if you were dividing to go from one to the other, the sister relationship to division is multiplication. Just like the sister relationship of addition is subtraction, division and multiplication are related to each other. So if you're going in the other direction, you're going to be multiplying. In a way, this is easier because all you got to do is just take this big whole number here, multiply it by the denominator. The reason why you're doing that is because every whole number has at least a denominator's worth of it. So like if your denominator is 14, then that means every whole number has 14 pieces to it. 14 14ths. So then you'd multiply 14 times however many whole numbers you had, and then add that to whatever's already existing on top. So in this case, we have 6 and 1/8. So what we're going to do is we're going to multiply 6 times 8. Sorry, my touch screen's a little sensitive here. 6 times 8. 6 times 8 is 48. However you get to that is fine. If you're slow with single digit multiplication, I would recommend just finding a multiplication table on Google, and then just kind of looking over it a few times, and then it should come to you. If not, if you wanted to break this down and be like, okay, well, I know 6 times 2 is 12, and there's 4 of those, so 12 times 4 is 48, because 2 times 4 is 8, and 4 times 1 is 4. You can do it like that as well, but it will make things a little bit easier if you do go through like a multiplication table and just kind of memorize those relationships through like 12 times 12. 12 times 12 is 144. But so a lot of time people go through 12 by 12 or 15 by 15, but 10 by 10 should be good enough, or 11 by 11. Because 11 by 11 is 121. It seems so easily to be 111, but there's an extra 11 on the back end, so it's 121. So knowing that 6 times 8 is 48, all you got left is that extra 1 that's on the numerator. So 48 plus 1 is 49. And then you have your 8, and then you're done. Now, is that simplified? Is 49 divisible by 8? No. Is 49 divisible by 2? No, I see people shaking their head no. Is 8 divisible by 7? Because 49 is 7 times 7, so is 8 divisible by 7? No. So that, yes, this is a simplified fraction. So even though it seems like 49/8 could be something simpler, it's not. Just like 22/7 seems like it could be simpler, it's not. One of the ways in which it becomes easy is if you have 1 on the top, it's always simplified. And then if you have 2 prime numbers that aren't the same, it's simplified. Generally, yeah, if you have 2 prime numbers, so if it's 2/3, 2 is prime, 3 is prime. I guess I should explain what a prime number is for those of you who haven't seen that in a while. Prime number means that the only things that can be divided by are itself and 1. So 2 is only divisible by 2 and 1. 3 is only divisible by 3 and 1. 5 is only divisible by 5 and 1. 7 is only divisible by 7 and 1. And then 11, 13, 17, 19, 23, 29, 31, 37, 41, 47, 53, 59. Those are the prime numbers going up to 60. Basically, 59 can only be divided by 59 and 1. 23 can only be divided by 23 and 1. So we'll get into simplification techniques and rules and things like that and all these at once, but just wanted to, while we had an extra example here, to see if it was simplified or not. So the denominator does not change when we multiply by the denominator times a whole number. The denominator will change if we multiply fractions together, but if we're just trying to convert something from a mixed number to an improper fraction, then the whole number times the denominator does not change the bottom. Yeah. So again, here's where we go with simplification processes. So if we have a fraction that's like 24 over 30, 24 over 30, we can kind of conclude that it can be simpler than that, because 24 can be divided by 2, 30 can be divided by 2, 24 can be divided by 4, 30 can't be divided by 4, 24 can't be divided by 5, 30 can be divided by 5, 24 can't be or can be divided by 6, and 30 can as well. So, and then after that, they can't be divided by 10, 8, 24, etc. So there's a bunch of ways in which you can simplify this fraction. The good old-fashioned way is to start with dividing by 2. So if you divide by 2, this becomes 12, this becomes 15. So you divided by 2. Well, can 15 be divided by 2? No. Can 15 be divided by 3? Yes. Can 12 be divided by 3? Yes. Well, then you go to 4 over 5. And then bam, 5 is a prime number. So and 4 is not divisible by 5, so you're done. And since 2 times 3 equals 6, that's how we were able to get this 6 here as the largest common divisor. So 24/30 is equivalent to 4/5. So that means if you had a 30 slice pizza and you ate 24 slices of it, it's equivalent to a 15 slice pizza where you ate 12 slices. And it's also equivalent to a 5 slice pizza where you ate 4 of them. Same relationship. So this one shows you that another way of solving this problem is you could have just divided 24 into 30 and realized, okay, you get a whole number there, but then you have a remainder. That remainder is 6. So you get one remainder 6. That remainder tells you potentially that the assuming that the numerator is divisible by that remainder, that you can take the numerator and divide it by that remainder and get a simplified numerator, and then do the same thing on the bottom, and then you get 4/5. And because there's no remainder here, you know that that's the most simplified it could be. Will this always work? Trying to think of an example where it won't off the top of my head. Generally, this should work, but there could be a case where it doesn't. So like, let's do, I don't know, 27 over 81. So if you do, actually, let's do it the other way around. Let's do 81 over, no, let's do 54 over 81. Okay, if you have 54 over 81, you would flip this around and go 81 over 54 is equal to 1, 54 remainder 27. If you do, let's see here, 54 divided by 27, you get 2. And if you do 81 divided by 27, you get 3. And so you'll realize that 27 is the largest divisor. So if you divide this by 27, you get 2. You divide this by 27, you get 3. And then that's your simplified fraction. So even on that one, it worked. And what that's finding is the greatest common divisor. The greatest common divisor is whatever the largest remainder, the largest value you can divide by to get a remainderless quotient. Now, if you have prime numbers, then that's just going to be 1, and then that means you're done. So like, let's say we have 3/19. Both of these are prime numbers. You do 19 divided by 3, you get 6. 18 is 1, so you have a remainder of 1. And then you have 3 divided by 1, and you get 1. Well, I think it'll work, because the reality is that your divisor will just be 1 if it's simplified as far as it can go. So in this example we just did, it's 2 prime numbers, so I know that we aren't going to have anything more simplified. And so again, step 1 is to divide 19 by 3. So we get 6, 18, 1. So you get 6 remainder 1. That's a 6 there. Now remember, what you're supposed to do then is take the numerator and divide it by the remainder, which is 1, and we get a whole number. So that means we know this is the greatest common divisor. So it's 1. So that means that this is already finished and simplified, because if you divide this by 1, you still get 3, and you divide this by 1, you still get 19. Any other questions behind this? And again, there are different ways. Like if you would have done this the way I did in the previous slide and you get to the answer, that's fine. It's just that sometimes this way might be a little bit more cumbersome. And in this way, if you feel comfortable with this way, then do it this way. But if you think it's weird to like flip the fraction upside down, divide it, and then divide that fraction to something else, and then you have like 6 different division problems just to simplify this, and that seems too complicated to you, that's perfectly fine. It's whatever you're comfortable with. So I'm just trying to give you different techniques, and if one really resonates with you, do that one. When I assess you on the problem, it's just going to be finding the divisor, finding the least common denominator, simplifying the fraction. And so if this way works for you, great. If this way works for you, great. I just want you to see different techniques to see how you can feel comfortable with it. Other simple ways to simplify whether something's divisible or not, little tricks, are these divisibility tests. So if your number ends in an even number, so if it ends with a 0, 2, 4, 6, or 8, then it's divisible by 2. Both the numerator and the denominator have to be divisible by, have to end in that in order for this divisibility test to work. So that's the simplest one. That's the one I did with 24/30. If they're both even numbers, you know you can divide them both by 2. When it comes to 3, this one's a little interesting. I trust the math experts and math historians. I've always thought this was like magic when I first learned about this divisible by 3 test. The reality is that if the sum of the digits are divisible by 3, meaning that the sum of the digits are equivalent to something that's like 3, 6, 9, 12, 15, 18, 21, etc., then both can be divisible by 3. So it might not seem like 36 or 69 is divisible by 3 on its face, but if you add 3 plus 6, that's 9. 9 divided by 3 is 3, so it's divisible by 3. 6 plus 9 is 15. 15 divided by 3 is 5, so that's divisible by 3. So it's really fascinating to know that you can divide this out by 3 because of this weird quirk. Let's say we have 39 divided by 117. Does 39 divided by 117 look like it's simplifiable? or both of them are divisible by 3 on their face. Maybe they do, maybe they don't. But if you add 3 plus 9 together, you get 12. If you add 1 plus 1 plus 7, you get 9. 12 and 9 are both divisible by 3, which means that this fraction can be simplified further. So if you divide both these sides by 3, you end up with 13 divided by 39. Oops. Now, is that simplified? Well, we can do the 3 test again to see if it's divisible by 3, because they're both even odd numbers, so we know we can't divide by 2. Well, it turns out that 1 plus 3 is 4. That's not divisible by 3, so 13 isn't divisible by 3. In fact, 13 is a prime number, so 13 can only be divided by 13 and 1. But 39 is divisible by 3. And 39 divided by 3 happens to be 13. So if we know that 39 can also be divided by 13. So if 13 divided by 13 is 1, 39 divided by 13 is 3, we simplified this all the way down to 1/3. And we got started because we knew that the sum of those digits were both divisible by 3. Four. If the last 2 digits are divisible by 4, then you get a you can break this down by 4. The reason why anything beyond the last 2 digits is unnecessary is because anything in the hundreds or thousands is divisible by 4, because if you think about it like this is really just 100 plus 40, or 200 plus 40. And so 200, 100, 300, 1,000, all of those are divisible by 4 because we have quarters. So a quarter is 25 cents times 4 is 100 cents. So we know that it's divisible by 4. So the only time in which you might run into problems where something isn't divisible by 4 is if these last 2 digits are not divisible by 4. So like 149 is not divisible by 4 because 49 is not divisible by 4. 140 is divisible by 4 because 40 is divisible by 4. 40 over 4 is 10. So when we do this, we end up getting, you can actually, if these have the common hundreds digit or thousands digit, you can just ignore that. And you can just focus on the last 2 digits of 40 over 60. And 40 divided by 4 is 10. 60 divided by 4 is 15. So you end up with 10 over 15. Well, these are also divisible by 5, so you end up with 2/3. 35 over 40. I don't know why this one's in here because that should be with 5, but 35 is not divisible by 4. 40 is, but 35 is divisible by 5, so that gives you 7. And 40 divided by 5 gives you 8, which is here. I don't know why this ended up here, but this is 5. If it's divisible by 5 or 0, then it's divisible by 5. So for 5, if your last digit is 0 or 5, it's divisible by 5. Think about nickels. Just like quarters, anything that's whole divided by 4 is divisible. Just like nickels, like if you have anything that ends in a 0 or 5, then it's divisible by 5, unless it's 0 itself. So if we have 15 over 20, we can divide these both by 5, we get 3/4. When we get to 6, if the number is even and the number is even and 3 will divide into the sum of the digits. So let me explain that. So odd numbers are not divisible by 6. It just look at a times table. Any number multiplied by 6 is even. Even multiply it by 3, it's 18, 24, 30, 36, 42. So if a number is odd, it automatically is not divisible by 6. It's not divisible by 16 either. But just because it's an even number doesn't mean it's divisible by 6 either. In order for us to determine that it's divisible by 6, we have to make sure that we use the 3 test. This 3 test, so it has to be even and it has to pass the 3 test to be divisible by 6. So 1 plus 2 is 3. That's divisible by 3. 1 plus 8 is 9. That's divisible by 3. So we know this is divisible by 6 because they're both even. So 12 over 6 is 2. 18 over 6 is 3. And then for 10, it's just that the last digit is 0. If it's anything else, then it's not divisible by 10. So divisible by 10, you get 9. Divisible by 10, you get 10. So does anybody have any questions about that? While I'm doing that, I'm going to start sorting these M&Ms out as quickly as I can. So that way we can start determining what fractions exist related to these M&Ms, assuming they aren't melting from my cooling fan in my laptop and just the general heat that's existing in my house right now. So I'm very curious to see. In fact, what I actually thought about doing, and you're welcome to do so if you want to, and you don't have to if you don't want to, is I thought about for next class, you should all bring in, or you don't have to actually bring it in live, but you could do it on your own. If you're an M&M's fan and like eating them, you can buy your own little $1 like movie theater style box of M&Ms and then sort out all of the M&Ms and then count how many in total there are and how many of the total you have. And then everyone can bring in their data. We can generate like a class data set on this. So for the statistics part of the course, we can do averages and stuff. But for the fraction and decimal portion of this class, we can determine the decimals and fractions unique to your specific box. So that sounds interesting. You can go for it. I would recommend regular M&Ms because then they each have their, I think, was it 6 colors? 6 colors. And then if you use Skittles, there's only 5 colors. If you use like special flavored M&Ms, they might only have 2 or 3. So I have now divided all of the M&Ms into 6 specific colors. And so I'll be ready for when we get to that part. Now, the question is, what if we want to convert the numerator? If we have a different denominator or vice versa. Let's say we want to convert 4/7 into 28ths. So maybe we have 4/7 of something, but we want to scale it up to being out of 28. If that's the case, then what we're going to do is we're going to divide the old denominator, or excuse me, the new denominator by the old denominator. So if we have 28 now, and we had 7 before, we're going to actually divide 28 by 7, and that gives us 4. So what is that 4? That 4 is basically what's known as a scalar, which is what we're going to scale up the numerator by. So if 28 divided by 7 is 4, that means that we need to multiply 4 by 4 to make sure that the fraction is still consistent. So when that's the case, we multiply 4 times 4, we get 16, and we now get 16/28 as our fraction. Again, it's not simplified, but it's still a proper fraction. And if we want to scale up for whatever reason, we now know that it's 4 times whatever it was before. So just like if we wanted to convert, I don't know, 3/5 into x over, I don't know, 30. Okay, well, 30 divided by 5 is 6. So we're going to multiply this times 6, and 3 times 6 is 18. So this will become 18 over 30. I'm so sorry that the M&Ms were sold out. I did not know they were in popular demand. Although every time I go to the store to buy tennis balls, they're always gone. So I haven't played tennis much this summer because for some reason there's just been a run on tennis balls all year. So if you want to convert anything upscalar, you just divide the denominators and then you multiply whatever the quotient is. Now, what about adding fractions? Adding fractions is super easy as long as the denominator is the same. If the denominator is the same, then it's very simple. You just add the tops together. I mean, if you want me to put these back in the box and send them to you, sure. I feel like, but I figure that I've touched them enough with my fingers. It's on my desk that the only person that should be comfortable eating them is me. I don't even know if I'm comfortable eating them now, but it's all for science or math for that matter. So adding fractions is very simple so long as the denominator is the same. If the denominator is the same, all you got to do is add the tops together. So 1/7 plus 4/7, it's just 1 plus 4 over the 7. It's not 5 over 14. It's not anything crazy. The denominator does not change when you add. The denominator does not change when you subtract. You might have to change it in order to get like terms, but when you add and subtract fractions, you do not change the denominator unless you need to make sure that they're consistent in terms of adding. When you multiply and divide fractions, the denominator will change, but the denominator does not change when you add. So if you have 11/12 and 1/12, you get 12/12. That's 1. If you get 5/9 plus 6/9, that's 11/9. You can convert that to a mixed number. It's 1 and 2/9. So if I wanted to convert to a mixed number, I'll tell you. So if we have 1/17 and 4/17 and 9/17, then the answer is going to be 1 plus 4 plus 9, which is 14 over 17. Notice the denominator didn't change whatsoever. The only thing that changes is the numerator. Basically, the way you can think about this is, let's say that you have a 17 slice pizza, okay? Assuming that the person that cut the pizza did it properly, all of those slices are the same size, right? So if you were to take 1 slice of that pizza and 4 slices of that pizza and 9 slices of that pizza, and you added them together and tried to make them into a pizza, it would look like 13/17 of a pizza when you're done. The problem that happens is if you have an 8-slice pizza and a 17-slice pizza and you want to combine them. They're not the same size slice. So the numerator is representative of how much of the whole it is. So a 17-slice pizza is going to have much smaller pieces than an 8-slice pizza. So if you added 1/8 and 1/17, you wouldn't get two. What would you get? Because you wouldn't get 2/17. You wouldn't get 2/8. You wouldn't get 2/25. So there has to be a conversion process that happens when they're not the same scale. So if they're not the same, then what we need to do is we need to find what's known as a least common denominator, or an LCD. So LCD was like the TVs in vogue in 2007, but what we're really talking about here is the least common denominator. So the least common denominator is basically saying, what is the simplified denominator that allows for us to add this together? So if we have a 21-slice pizza and we have 5 slices of that, and we have 3 slices of a 7-slice pizza, how much pizza do we have at the end of it? Well, the problem is you can't scale down 521, because 21 can go into 7 3 times, but 5 isn't divisible by 3. It's not divisible by anything except 5 and 1. So we can't scale down to 7. We could scale up to 42. The problem is that it's possible to scale up before we get to 42. If you turn 7 into 21, then we don't have to go any further than that. So the reality is that if you scale up 7 times 3 is 21. So you can change this to 21 very easily. Remember before when we were trying to determine the appropriate amount in the numerator? Well, if we're multiplying 7 times 3 to get 21, then we also need to be consistent and multiply the top times 3. So that should give us 9. This is already over 21. So now we have common denominators, and we can just add this like before and get 14/21. Can 14/21 be simplified? Yeah, it can. Now, what is it divisible by? 14 is not divisible, or 21 is not divisible by 2. 14 is not divisible by 3. Neither of them are divisible by 4 or 5 or 6, but both of them are divisible by 7. So if we divide both of these by 7, we get 2/3. So if you take 3 slices of a 7-slice pizza and 5 slices of a 21-slice pizza together, you would get a Pac-Man pizza of 2/3 of it being filled. I actually don't know what the ratio of Pac-Man's mouth to its body is, but let's just say it's 2/3. So 1/3. 1/3, and then if you fill in all this, then you get Pac-Man. And then you got to give him his little pellets to eat. So there you go. So we took a 21-slice pizza and a 7-slice pizza, we merged it together, and we got Pac-Man. 2/3. So that's the least common denominator. Technically, you could have scaled up to 42, and you would have gotten, let's see here, you would have gotten 28/42. That would have been fine, because if you're going to simplify it anyways, you're going to get 2/3 at the end. But it saves you a little bit of time in terms of the division problem if you're able to nip it in the bud right away and find the least common denominator right off the bat. So I'm not the type of person, I might ask you a couple questions to find the least common denominator in the homework and the quiz, but I don't think that's the most important thing. I think it's important that you find a common denominator. If it happens to be the smallest one, that's fine. But chances are you're going to simplify it anyways after the fact, and then you might end up getting to the least common denominator that way, or you might end up to a simplified fraction beyond it. Because yes, the least common denominator here was 21, and that allowed for us to add the like terms and actually determine what the sum of the 21ths was. But at the end of the day, it's still 2/3, and that's really what the answer is. Sorry, there's someone. I need to admit someone to the waiting room or from the waiting room. Okay. So if we're adding unlike fractions, we need to find a LCD or least common denominator. So we have 3, we have 8, we have 9, we have 12. Well, how do we find the least common denominator? Well, can we scale up 8 to 12? No. Can we scale up 9 to 12? No. So we know that 12 is not the least common denominator. Can we scale these down to 3, 8, or 9? No, because it's 1 on top, which means we know that these fractions are as simplified as they possibly can be. So the next question is, how do we find the least common denominator? Well, one way in which we can do it is we can just do trial and error. But what ends up happening is in this one, we'll end up with 72. So why did we get 72? We could have tried 24 because 12 times 2 is 24, 3 times 8 is 24, 8 times 3 is 24, but is 9. 24 divided by 9 give us a whole number? No, it doesn't. So 24 is out. 36 is out. And the reason why I'm going up by increments of 12 is because 1/12 can't be simplified any smaller than 12. Does that make sense? So if it was like 2/12, I could make that 1/6, and then yeah, we could use 6 division. Then we go by 9s because 9 is the smallest number. Because 12 is the smallest number, we have to go by increments of 12. So we did 12, doesn't work. 24, well, 3 goes into 24, 8 goes into 24, 9 doesn't, 24 is out. 36, 9 goes into 36, 12 goes into 36, 3 goes into 36, but 8 doesn't, so that's out. 48, these don't. 60, whoops, whoa, I have no idea what just happened. Whoa. All right, there we go. 60. Can 9 go into 60? No, not a whole number. 72, okay. 72 divided by 9 is 8. 72 divided by 8 is 9. 72 divided by 12 is 6. And 72 divided by 3 is 24. We finally found it. It's 72. So that's how we found it. Does that make sense? So sometimes there's no cool, awesome rule for it. It's literally just, okay, well, these are all simplified. So the largest denominator, we're going to go by increments of the largest denominator until all of them are divisible by their denominator. So now that we know that 72 is the least common denominator, we need to scale these up to 72. So how much do we need to scale this up by? 24. So we end up with 24 over 72. 8 times 9 is 72, so this becomes 9. 9 times 8 is 72, so this becomes 8. 6 times 12 is 72, this becomes 6. So we get 24 plus 9 is 33, plus 8 is 41, plus 6 is 47 over 72. So there's a little bit of critical thinking, a little bit of trial and error that comes with finding a least common denominator. But generally speaking, the simplest rule of thumb is if your fractions are as simplified as they can be, then take the largest denominator that exists, keep scaling it up until all of the other ones can be divided by it. So in this case, don't even worry about 3, 8, or 9 because 12 is bigger than all of them. So start by increments of 12. And we knew that 24 was not good enough. 36 wasn't good. 48 wasn't good. 60 wasn't good. All of them are divisible or 72 is divisible by all those other denominators. Now, could 47 over 72 be simplified? Is it 47 is not divisible by 2? 47 is not divisible by 3. 47 is not divisible by 4. Neither of them are divisible by 5. 47 is not divisible by 6 because it's not an even number. Neither of them are divisible by 7. 72 is not divisible, or excuse me, 47 is not divisible by 8. 47 is not divisible by 9. Is 47 divisible by anything besides 47? No, it's a prime number. So if you have a prime number there, unless the denominator is divisible by that same prime number, you're done with simplification. So any questions about anything that I've talked about so far? Okay. Speaking of prime numbers, here's a little, I like how conveniently the 47 is a prime number, but they cut it off at 43 on this slide. So we now know that 47 is next. Does anyone know what comes after 47 in prime numbers? It is not 49 because 49 is 7 times 7. But it's a good guess. 51. Well, if we go back to our rules, if you take 51 and you add the digits together, it's 5 plus 1, which is 6. So that means it's divisible by 3, which means it's divisible by 3. 51 divided by 3 is 17. So 51 is actually not a prime number either. $53 is the next prime number. And then 55 is divided by 5. 57 is divisible by 19. And then 59 is a prime number. 61, I think, is a prime number. 63 is divisible by 7 and 9. 65 is divisible by 5. 67 is prime. 69 is divisible by 3. 71 is, I think, a prime number. 73, 79, 83, 87, I think, is divisible by 29. 89 might be prime. There's actually a pattern. I think it's like 2, 3, 5, 7, 1, 3, 7, 9, 3, 9, 1, 7, 1, 3, 7, 3, 9. Well, I'm just pretending that I know the pattern, but I'm just reading off the numbers here. But I think there is a pattern that once you get past a certain digits, it starts to repeat itself, where it's like 1, 3, 7, 9 for one set of tens, and then like 3, 9, and then 1, 7, 9, then 1, 3, 7, 9, and it keeps going on and on. But yeah, so you shouldn't really need anything beyond that, because I don't think I'm going to give you something where it needs to be divisible by like 83. So yeah. So the other way, again, I'm not saying this is the best way or the way you should do it, but it's a different format to try and understand how to find a least common denominator. So when you have the least common denominator, I'm actually going to ignore the steps here. I'm just going to draw things out instead of the words. You can go back and look through the words. So what we want to do is we want to find prime numbers that are within the denominators. So of these digits, how many of them are divisible by 2? 2 of them are. So this little table says, okay, If I take all of the denominators that exist and divide them by 2, if I divide them by 2, this one doesn't change because I can't do it. This one doesn't change because I can't do it. Because I can divide this by 2 and divide this by 2, I get 4 and 6. So here I get a 2. This first line is what is the equivalent to this. These are the same. But now I have 3, 4, 9, and 6. I try to divide those by 2 again. And so I put a 2 here as well, because we end up converting this down to 2 and this down to 3. This is still 3. This is still 9. Well, what if we divide these by 3? Because 3 is also a prime number. Because none of these are, well, yeah, none of these are divisible by 2 except the 2 itself. So we're going to leave that one alone. But we can divide these by 3. So this becomes 1, this becomes 3, this becomes 1. So we multiply by 3. And so what we have are, we multiply these, and then we multiply these numbers by these numbers that remain. So we do 2 times 2 times 3 times 1 times 2 times 3 times 1. This is something that's known as prime factorization. And you end up with 2 times 2 is 4. 4 times 3 is 12. 12 times 1 is 12. 12 times 2 is 24. 24 times 3 is 72. Times 1, you get 72 as your least common denominator. Personally, I've never used this table before. I've done prime factorization before, but I haven't used this table. So if this table doesn't make sense to you, that's okay. Another way you can just do it is just by being like, okay, we have a prime number. We can take out of these numbers what's left over. Prime number of this, what's left over. Prime number of this, what's left over. So if you do that, you get 3 times 2 times 3 times 2 times 3 times 2 is 6, 18, 36 times 2, which is 72. Let's see here. Does anybody have any questions about finding the least common denominator, either this way or the other way? Okay. So what if we want to add mixed numbers together? Well, if you want to add mixed numbers together, you don't have to worry about the whole number. The only thing that you have to worry about is the fraction and converting that to a least common denominator. And then the whole numbers are just whole numbers. So like if you want to do them first, that's fine, but you might want to wait until after you've converted the fractions and then see if you have an improper fraction, convert that to a mixed number, then add those whole numbers. Whatever's more comfortable for you is fine. But the reality is if you have 4 and 7/20, 6 and 3/5, and 7 and 1/4, the 4, the 6, and the 7 are going to be added together no matter what. So you have at least 17 in the whole number section. 7/20, 3/5, and 1/4 are not of a common denominator. So in order for us to add those fractions together, we need to convert them to a common denominator. So if we do that, we can try to determine what the least common denominator is, which in this case is a little bit easier. 7/20 cannot be simplified, so we know the smallest denominator it could possibly be is 20. Well, can 5 scale up to 20? Yes. Can 4 scale up to 20? Yes. So instead of us having to find some big number out there, the good news is that 5 and 20 are divisible, 4 and 20 are divisible. So we're just going to scale up to 20. 5 times 4 is 20. So we're going to multiply 3 times 4. That gives us 12. If we're going from 4 to 20, 1 times 5 is 5. So we get 5 over 20. And then the 7 over 20 remains the same. So 7 plus 12 is 19. 19 plus 5 is 24. So we end up with 24 over 20. Now, if we're trying to add mixed numbers together, remember we already have 17 from these digits right here. But when we convert 24 over 20 into a mixed number, we get 1 and 420. So that means we need to add this 1 to this 17. So we get 18, and what's left over is 4/20. If we want to simplify this, then we can go back to our table. Are these divisible by 4? Yes. So we end up with 18 and 1/5 as our answer. So any questions about fraction addition? Okay. Well, we have some wonderful M&Ms here that I have sorted out. And so what I'm going to do now is I'm going to let me stop the screen share for a second and edit this slideshow so I have an extra slide here. And I will share my screen again. So now you should see a blank slide. So if you are familiar with M&Ms, there are 6 distinct colors. You have red, you have blue, you have yellow, you have, we're going to use white for brown because I don't have a brown color on my screen, orange, and green. So drop in the chat, what's your favorite color M&M? Red, orange, yellow, green, blue, or brown? Lots of people saying red. Does that mean red is your actual favorite color, or is it your actual, or is it just your favorite M&M color? Is there a correlation between your favorite color and your favorite M&M color? Just the favorite one. Interesting. Trying to think, there was has anyone seen the movie with like Jennifer Lopez, like the wedding planner or whatever? There's like a scene where she's, I guess, afraid of, she only likes brown M&Ms because that's the natural color of chocolate. And so, so does anyone want to guess mine? My favorite color is orange. It looks red, but it's orange. Orange has always been my favorite color. Although in terms of like what I like green a lot too now. So I would go orange is my favorite color growing up. Green has become my like favorite color over the past 10 years. Orange is my favorite color because I thought it was the least common color that people said was their favorite color. I liked how loud it was. And I'm also from the Cleveland area. And so like the Browns are my favorite football team and their helmets were orange. And I thought that was cool. So that's where orange came from. And then green I like a lot because of my college's alma maters are green was part of the color scheme. So I like green as well. But my bottle is green. But anyways, So I don't really actually have a preferred M&M color. Honestly, I just eat them. I just open the box and dump them in my mouth. I don't really pick and choose. Skittles, on the other hand, they actually have flavors attached to them. So then I'm picky and choosy there. So I've sorted all these out, and we happen to have 2, 4, 6, 8, 10, 12, 13 red M&Ms, which appears to be disproportionately small when you have 105. So I'm sorry for all of you who have really liked the red ones. Didn't get many this time. I'll jump to yellow next because it's the closest one. 2, 4, 6, 8, 10, 12, well, 2, 4, 7, 10, 13, 15, 17 yellows. Oranges, 2, 4, 6, 8, 10, 12, 14, 16, 18, 21 orange. Brown, we have 2, 4, 6, 8, 10, 12, 14, 16, 17 brown. Green, we have 2, 4, 6, 8, 10, 12, 15 green. And so what did I say? We had 105. So we have 30, 47, 68, 83. So we should have 22 blue. But I will confirm 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So that does confirm that we had 105 M&Ms. So our total is 105. So in a simplest form, our fractions here are going to be 13 over 105, 22 over 105, 17 over 105, 17 over 105, 21 over 105, and 15 over 105. Okay. How many of these fractions do you believe can be simplified? Any of them? One of them? Two of them? Any colors?
Can't all of them be simplified?
Is 105 divisible by 13?
No.
So that means that red cannot be simplified because red is not red. 13 is a prime number, which means that unless the denominator is not divisible by said prime number, it cannot be simplified. So red is actually done. Can blue be simplified? Well, the numerator can be divided by 2, but the denominator can't. I don't think, actually, 105 can be divisible by 3, but 22 cannot. 22 is not a prime number, but it can't go into 105. 22 can't be divided by 5. 22 can't be divided by 6. And 22 can't be divided by 10. And 105 can really only be divided by 5, 21, and that's about it. So blue is not simplified. Can yellow be simplified? Yellow cannot be simplified because yellow 17 is a prime number and 105 is not divisible by 17. So this one is not simplifiable. And brown is the exact same ratio, so that's the case. Orange, on the other hand, can be simplified because 105 and 21 Both of these are divisible by 3. It actually happens to be that they're both divisible by 21, but we can start with 3 because 2 plus 1 is 3, that's divisible by 3. 1 plus 0 plus 5 is 6, that's divisible by 3. So we do that, we end up with 7 divided by, it's 105 divided by 3, I think that's 35. Well, 7 is divisible, 35 is divisible by 7, 7 is divisible by 7, so we end up with 1/5. So it turns out that 1/5 of the box is orange, which is more than you would expect because the box has 6 colors. Green, Bethany said that green is divisible by something, which is true. If we use the 3 method, we know that this is divisible by 3. We also know this is divisible by 5. Well, 5 times 3, if it's divisible by 3 and it's divisible by 5, we also know that 5 times 3 is 15, so we know it's divisible by 15 as well. So we can go the long way and we can say, okay, this is 5 over 35, and then divide by 5, and we get 1 over 7. But if you just divided it by 15 to start, then you would get 1 over 7. So 2 of these were able to be simplified. So we know that green is representative of 1/7 of the box. We know orange is representative of 1/5 of the box, and then the other ones are divisible by 105. And then if we wanted to convert this back into a least common denominator, we know that the least common denominator is 105 because that's what we started with. So does anybody have any questions related to this? Okay, so because of the syllabus, we didn't get through as much as I anticipated today. So what I will do is I will push back the due date of the homework back a week as well as the quiz. So you won't have any homework due this week because I want to make sure that you feel comfortable with subtraction, multiplying, dividing, all that stuff. Decimals will be a lot quicker than fractions, I think, because a lot of fraction or decimals are derived from fractions, and you're usually dealing with decimals more often when you're dealing with like dollars and cents and stuff like that. So hopefully we will be back on track after class next week.